In the early days of cloud computing, we treated databases as separate servers that we managed, patched, and scaled vertically. But now in 2026, the paradigm has shifted into what is known as data gravity. This is where the data warehouse isn't just a place to store numbers, but it's the programmable heart of your infrastructure. So if you're a cloud engineer today, SQL is no longer an optional skill for analysts, but rather a very important and very essential skill and almost mandatory language for infrastructure monitoring, security auditing, and cost governance. So every log your application generates, every billing line item from your cloud provider, and every user event is likely to land in a planetary scale data warehouse like Google Cloud BigQuery. And what makes BigQuery the industry standard for cloud engineering isn't just its speed, but its serverless distributed architecture that separates storage from compute. In this video, we're going to look at SQL through an architect's lens. So we're not just going to learn how to fetch data, but we're going to learn how to manage thousands of parallel workers with a single query. We're going to learn how to optimize our scans to save thousands of dollars in our cloud bills. And we're gonna see how to build automated auditing systems that treat your data as code. Now, to write professional SQL, you have to understand the physical contract between your code and the hardware. Traditional relational databases like PostgreSQL or MySQL are row-oriented, meaning they store all data for a single user in one block on a disk. This is great for looking up a single profile, but it's a disaster for analytics where you only care about one specific field like total spent across a billion rows. BigQuery solves this by using columnar storage. So instead of reading an entire row to find a single value, BigQuery's execution engine known as Dremel only reads the specific columns that you mention in your select statement. Now, this leads us to the most important rule in Cloud SQL, and that is the select all command. Now, the select all command is an architectural failure. In BigQuery, you are billed by the volume of the data scanned. When you run a query, BigQuery's query validator tells you exactly how much data it will process before you even hit run. For example, by explicitly naming the 3 columns that you need from a 100-column table, you're essentially reducing the infrastructure cost and the latency or the query latency by 97%. This is why cloud engineers don't just write queries, they manage the scan surface of their data. Now, once you understand how BigQuery reads data, the next step is learning how to structure it. As an engineer, you don't just use create table to define names and types. You use it to define the physical distribution of your data. Now, this is where partitioning and clustering comes into play. Partitioning is the process of slicing your data into drawers based on a date or timestamp. If you have 5 years of logs, a partitioned table allows your SQL to ignore 4 years and 364 days of data if you only query for today. Now, the real magic happens with clustering. While partitioning defines the physical boundaries of the data, clustering optimizes the internal storage blocks, ensuring that the related values are collocated for faster retrieval. For example, if you cluster your logs by user ID, BigQuery stores all entries for that user in the same physical block. This means when you run a query for a specific user, the engine doesn't just skip dates, it skips blocks within those dates. Now, let's put that theory into practice. We're going to build a production billing auditor that turns millions of messy raw infrastructure logs into a surgical report of your top cost drivers. Now, before we touch the console, we need to be clear on the objective here. We're building an automated data pipeline, so we need to define the source, which is the raw, unorganized billing data from every GCP resource you own. And the logic is, of course, a high-performance SQL script that skips irrelevant data to save money. Now, we want the result to be a top 3 leaderboard of where your money is going per project in real time. Now, first we're going to connect the source to the database. So we're going to create the data set. So I'm going to open the BigQuery console, and then we're going to click on the project ID and then click on create dataset. So first we're going to give it an ID, let's say infra operations. And then I'm going to choose multi-region as the location. This is because multi-region allows Google to backfill the last 30 days of data. Now, we're going to enable the export, so we're going to navigate to billing and then billing export. Now, under standard usage cost, we're going to click on edit settings, and we're going to select the project and of course the infra operations dataset that we have just created, and then we're going to click on save. Now, once you hit save, Google's background services begin the synchronization. So if we go back to the BigQuery page and click on the dataset, you will see that it's empty. We've got no tables here. So we might need to wait a few minutes for the system to physically create the table container in the storage layer. And now that we waited a few minutes, I'm going to click on the of course the data set, and as you can see, we've got the table created. And with the data flowing, we can now write our contract. So of course we're going to click on SQL query, and I'm going to write my code. Of course, this script is designed for high performance cost management. Do not forget to change the ID of the table. You can find it in here by clicking on these 3 dots, and then you can click on copy ID, and of course you can replace your actual table ID with that in there. So as I said, this script is designed for high performance cost management. So with daily costs command, so with daily costs here, it creates a temporary workspace allowing us to clean the raw data before we perform the complex ranking. And as for the sum command here, it takes thousands of microtransactions and rolls them up into a single readable number for each service. And as for the rank, so as for the rank over, this is a window function, and it treats each project ID as its own separate group and calculates a leaderboard of costs within that group. And as for the qualify command, this is a powerful BigQuery specific command that filters the results after the ranking is finished, ensuring we only see the most important data. So as you can see now, this query will process, this query will process this small amount of data when run, and that is because my billing data is very small. So I'm gonna go ahead and click on run. So you will see a ranked list showing your top 3 spenders per project, and of course we're talking about in this time range which we have specified in the code. And the reason why it's a top 3 spenders is because we have specified that in the code right here. Of course, we're talking about the top 3 spenders per project, as you can see in here. Now of course you can notice the null ID here. So this is normal as it represents account-wide costs like taxes or invoice level adjustments that aren't tied to a specific resource. So who uses this? Well, you've just created data as code asset that serves three different types of clients. We've got the executive client. So you can connect this query to Looker Studio, and now this CFO, this client, has a real-time cost leaderboard that works in milliseconds because the SQL is optimized. We got the automation client where an engineer can wrap this in a cloud function. So if the top one service in any project spikes by more than 50% overnight, the script fires a critical alert to Slack. Also, since the data is in BigQuery, you can cross-reference these costs with your access logs to see exactly who triggered the resource that caused the cost spike. Now that's it for today's video. I hope everything was clear. If you've got any questions, drop them in the comments below. And if you want to learn more about cloud and IT, check the link in the description below. Don't forget to hit that like and subscribe buttons, and I'll see you in the next video.